with optics now. Yes, now. Yes, are you there?
Yes, sir.
ఇది తెలుగు వచ్చు కదూ
Fine.
అర్థం ఉండాలి.
So let us start with optics. What is optics? Who can tell me?
ఏం చెప్తే చెప్పు.
Yes, what is optics?
అంటే మనకు తెలిసి కూడా చెప్తారా పని
Optics
మన
is nothing but
అర్థమైందా
optics is nothing
తెలిసి కూడా చెప్తారు
but
పని
study of light. Yes, what is optics? It is
అడిగి
the
ఇక్కడే
study of
మీకు
light.
తెలియదు అని చెప్పేది
Yes.
In this chapter, we will study what light actually is. What light actually is.
ఓకేనా
It means
కూర్చో
it is made up of particles or is it made up of waves? Uh, what kind of matter is this light? Means everything whatever we are able to see in this whole world, they are nothing but matter, and that we are able to see because of light is falling over it and it is reaching to our eyes. But what actually light is it some particle? What kind of energy is it? This all these things we will see in this part, which is nothing but optics. Okay, so now study a general historical note before we start our full chapter. This light, it has always fascinated humans since
అమ్మ
time immemorial.
రామా
Primary sources of light are sun and moon and stars, and as well as then human discovered fire. So fire became a source of light. Lamps, they became a source of light. Okay. So what light actually is, uh, it has been described by several ancient philosophers also. Like specifically speaking of India,
అందరు
there is a darshan, Vaisheshik darshan. It is one of the six philosophical systems of ancient India: Sankhya, Yoga, Nyaya, Vaisheshik, and Uttar Mimamsa, Purv Mimamsa. They are six darshans of ancient India. So in this Vaisheshik darshan is there, which was written by Kanad Muni. So in that he described light as streams of particles made up of energy, made up of urja. Actually, he called them as Tejas Anu. Tejas means heat, and Anu means particle. So particles of energy. Tejas means tej, means that fire, and Anu means particle. So particles of energy. It is described now. In that description, he comes very near to the modern description of light. It is nothing but uh, quantum of waves. Waves is nothing but energy. Wave is disturbance or energy which is being carried forward. Okay, so here he comes very near to the modern description of light. Light has seven colors. It has also been described by ancient philosophers of India. Like one of them was Varahmir. He described that light contains seven colors. Similarly, in Europe also, the development on what light is was proceeding independently. Plato described it, and Egyptians described it. In Middle East, Sumeria, they discovered a lens. Means lens was already discovered. In India, lens was called Suryakant Mani. So all of these things were being developed in different parts of the world separately. We do not know now that if they were interrelated or not. Now, for modern understanding, it starts from 16th century with the revolution in Europe. Uh, corpuscular model of light was developed by one scientist whose name was Descartes. He gave corpuscles model or corpuscular model. What does this corpuscular model tell us about light? Corpuscular model tell us that light is made up of small particles. These particles are called corpuscles. These particles are called corpuscles. Isaac Newton described this corpuscular model only. He just expanded this corpuscular model and assumed that light is nothing but particle. He wrote a book called Optics, and several years after that, Christian Huygens was a scientist. That Christian Huygens, he opined that light is not made up of particles. In fact, light is nothing but a wave. He put forward a wave theory. For the first time, Christian Huygens, he put forward a wave theory, and that wave theory was found to be true later on. Huygens' principles were found to be true later on when Maxwell and Thomas Young, they performed several experiments on light, and they found that yes, Huygens was right. Some of the things he was wrong fundamentally, but his theory was fine. There was nothing wrong with his theory. Thomas Young performed a double slit experiment that we will study in our wave optics. That is called as Young's double slit experiment. In that Young's double slit experiment, he found that yes, light is interfering with one another. It is not traveling in a straight line path, which it should have had it been a particle in nature. But light is not a particle, that's why it is interfering, similar to the waves. This was proved by Thomas Young. And after that, Maxwell ultimately he proved that light is nothing but electromagnetic wave, an electromagnetic radiation, that is light. So this is the ultimate culmination which resulted in quantum theory of electrodynamics. It explains everything, means not everything, but almost everything about light, that light is nothing but electromagnetic waves which are coming out in form of packets. Means there are packets of electromagnetic waves. They are not continuous electromagnetic waves. They are packets, small packets, particles of waves. Means in a packet, like pasta, you might have seen penny pasta. So in that pasta, small pastas are there. Okay, individual pasta are there, and they are all inside a packet. Similarly, packets of wave are there. Means several waves are packed together and they are given as a unit. That unit is called as a photon. That unit is called as a photon. Okay. So this was just a introduction about wave theory of light. Am I audible to both of you? Is this meeting going fine?
Yes, sir.
Fine. Fine then. Now, this optics have two branches. Yes, Hemant, am I audible clearly?
Sir, you are audible clearly, sir. No issues.
Fine. First part is geometrical optics, and second part is wave optics. Geometrical optics is nothing but Newtonian optics. It works on the corpuscular model of light, which was proposed by Descartes and expanded by Isaac Newton. Okay, and wave optics discusses what actually light is. So it discusses the wave aspect of light. Okay, so but how can we identify that right now we need to solve the problem with geometrical optics, and but after this point we need to shift over wave optics? How can we identify that? So first point of our optics is this: in geometrical optics, always remember that light is assumed to be traveling in a straight line. It does not travel in a straight line, but it is assumed to be traveling in a straight line. Write it down: in geometrical optics, light is assumed to be traveling.
Sir, why it is assumed to be travel? Like, why can't in waveform only we can study directly, sir?
Good question. We Assume it to be traveling in a straight line because of this. What is written here?
Geometry.
Geometry. Now, what is geometry? Straight lines.
That one.
Geometry is nothing but mathematics.
It's
In
a
mathematics, the yeah, the lines, the geometry, the graph, which whatever you have studied under this topic, geometry, all those things can be applied to light if it is traveling in a straight line. If it is traveling in a straight line, then we can apply the basic principles of geometry here also. Here also we can apply the basic principles of geometry. And yes, we will get the results. We will get the results by applying these principles of geometry. How is it happening? Because it is following laws of geometry, but up to a certain extent only. After that extent, it does not obey the principles of geometry. So from that point onwards comes wave optics. From from that point onwards, our picture will be shifted towards waves. Or before that, we can study each and every phenomena of light using the geometrical principles. And in geometry, easiest way is a straight line. The geometry of a straight line where it is going to intersect the x-axis or y-axis, that is easily understandable. And because we want to understand how the things are happening, how we are seeing the rainbow, how uh, an optical fiber is working. Now, in these simple cases, we can use geometry.
sir. When
That's why it is called geometrical optics.
sir can
Yes, what are you asking?
so since light is actually it's a wave motion, we can say electromagnetic or anything. It will have wavelength and
Yes.
frequencies motion.
Yes.
Sir, in this geometrical optics, we discuss lenses, all these types of mirrors and objects, everything like that.
Yes. Yes. Yes.
So the wavelength is very small compared to length of human or any object. No, sir. Like that also
Is
we can
where
see.
see this we will study. This we will study. Validity of ray optics and wave optics. This is our next topic only. Uh, it happens so that when the particle or the obstacle, or we can say the object in the path of light is very, very small, it is very, very small. In that case, the light will not obey the principle of geometry. In that case, it will show its wave nature. Now, what is that limit? What is that very, very small limit? That very small limit is actually the wavelength of the light. If the size of object is comparable with the wavelength, then wave nature we will see. But if the size is very, very large, then the wavelength, then we will not see wave nature. We will see its particle nature only. For us, the wave will be just a straight line, just for us. Okay. In reality, at quantum level, it is still wave, but because our object is so huge in comparison with the wavelength of light, so it will act as if it is a straight line. Okay, so that we will study under validity of wave optics. First of all, let us write these points down. In geometrical optics, light is assumed to be traveling in a straight line. In a straight line. This property is called what? Rectilinear propagation of light. Rectilinear propagation of light. This is a property of geometrical optics. Now, using this geometrical optics, laws and principles of geometry can be applied to rays of light. Here we can apply the geometrical principles and can explain can explain laws of reflection. Laws of reflection can be explained by using geometrical optics. Refraction. Refraction can also be explained using geometrical optics. total internal reflection, TIR. Again, I am repeating, it is total internal reflection, etc. All these things can be explained geometrically. Laws and principles of geometry, they can be applied, and it can explain the laws of reflection, refraction, total internal reflection, and other phenomena as well. Okay, taken down this till this point. Shall we move ahead?
Yes, sir. One
Yes,
thing.
Hemant.
Yes, sir.
Fine,
Like,
fine.
We can move, sir.
sir, sir, I can't see that, sir. Like, it's in portrait mode, sir. This one. It's not covering full screen, sir. Come, I'll send you.
It's not covering full screen.
I'll send you a photo, sir. See.
Okay, if it is not fine, then we will continue from Google Meet. We have to continue with Google Meet only if it is not fine.
Yes, sir. Just see the see the WhatsApp message that I sent you. Yes.
Hmm. Oh, why is it happening? Yeah, it is in portrait mode. So
Can't see
is it
anything.
clear now?
No, sir. It's same.
Why is this happening? Hemant,
Yes, sir. I'm okay.
is full screen visible to you, or are you facing the same problem?
So for me it's visible, but it's in lands portrait method.
Okay. Okay, fine. So,
Or else we can
Chanakya,
continue with Zoom, sir. Like Zoom, we
yeah,
can.
let us continue with me. Let us continue with this class today, and
Mm,
from tomorrow onwards, we'll continue with Google Meet.
yes.
So, complete it till this point.
Awesome.
See, whatever we are writing over here, this PDF, I am able to send to you both. Okay, and recording also can be done in Google Meet as well as here. So, link of that recording, I will share that too,
Yes.
if possible. Let us see. Okay, then. Now, what happens in wave optics? In wave optics, light is considered as a wave. Huygens wave principle, superposition, these principles are used to explain interference and diffraction, polarization, all these things, polarization, interference, and diffraction. These three phenomena of light are not explained by using geometrical optics, but they can be explained using wave nature of light. Polarization and interference, diffraction, and diffraction can be explained using wave theory. They can be explained using wave theory, which proves light as a wave. So, here in wave optics, we use Huygens principle. Huygens principle and superposition. and superposition principle. To explain to explain above mentioned phenomena. Above mentioned phenomena. Okay. Now let us move towards validity of ray optics. Till what point, till till what limit we can use the geometrical rules, we can use the concepts of geometry to 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 be used in ray optics. Uh, so it is validity of ray optics. Means up to which point we can use the principles of geometry to understand the phenomena shown by light, its interaction with another light rays, and interaction with the objects or any opaque object, any hindrance in the path of light. This validity of ray optics, this is also known as Fresnel's distance or Fresnel distance. Fresnel's distance. Okay. Now, shall we move ahead? All done till this point?
Yes, sir. All done.
Yes, sir.
Hmm. Fresnel's distance. See, first of all, the assumption that light travels in a straight line, that will be correct only if the medium is isotropic. Means the medium is same everywhere. Medium is not changing in any direction. And second, the obstacle or any object across which the light is moving, or we can say the source of light, or we can say the window or the opening through which the light is coming, that is not very small. It means it should not be of the order of wavelength of light. Write down these truths. The assumptions, the assumption that light travels in a straight line, light travels in a straight line is correct if, only if first the medium is isotropic. The medium is isotropic. It means what? It means the behavior of medium is same everywhere in all the directions. Its behavior is same in all the directions. Okay. And next point is what? Next point is the object. The object past which the light moves. The object past which the light moves, or we can say any opening or any aperture, or we can say aperture or opening, aperture or opening through which the light moves. Opening the light moves is not very small. What do we mean by very small? By very small, we mean it is of the order of wavelength of light. Of the order of wavelength of light. Okay. Written till this point, Chanakya? Hello? Yeah, Chanakya, Hemant, written till this point?
Yeah, perfect.
Yes, done.
So done, sir.
Chanakya?
No, sir. No, sir.
Fine, fine, fine. Write it down.
Done, sir.
Done.
Yes.
Okay, fine. So this these were the two rules for the validity of real things. Now, but when it is not very large, means when the object or the obstacle, or we can say the opening of window, or maybe anything, it is very very small, or it is, we can say, it is comparable with the wavelength of light, then light will not obey the laws of geometry. What will happen then? See the diagram. If this is a wall, and on this wall this small opening is there, this small opening is there, okay, from this small opening, and this is a screen. Let us assume that this is a screen. Okay, this is a screen. Now what should happen when parallel beam of light will incident? When parallel beam of light will incident, what will happen? parallel rays of light are incident over this opening, what will happen? What should have happened? This light should have made a point, or we can say, same breadth should be appear over this point. Is it not? If the light is traveling in a straight line, then we must observe only a bright spot here. Is it not? But generally, this is not the case. What happens? The light deviates from its path. Light actually deviates from its path. It goes like this. Oh, like this. Light is bending in a smooth formation. It is bending in a smooth formation. Here, that much smooth I am unable to draw. It is moving like this. Okay. Instead of getting a bright spot here, I am getting this length. If the length of this
Amma,
opening was A, then the width of light what I'm getting here is B. Now it is making an angle. This is making an angle like this.
Amma,
This angle it is making. Okay. It is making this angle. This angle is, let us say, this angle is theta. And let us assume that the distance between the screen and the opening or the source of light is capital D.
Amma,
This is our midpoint. Okay. Draw this diagram fast. Drawn the diagram?
No, sir, no, sir.
sir, drawn, sir.
Fine. So this phenomena in which this light is bending, this phenomena is nothing but this is diffraction. It happens when the source is very, very small. When the source is very, very small. Okay. Yes, Chanakya, drawn. Shall we move ahead?
Yes, sir.
Hmm. So in this diagram, write down it is found that light strikes in a band of width small b more than a, which is more than a. Okay. This bending of light is called diffraction. This bending of light is called diffraction. Using wave theory, we can show that sine theta, theta we know, we have seen what is theta here. Theta is this angle. Okay. So using wave theory, we can show that sine theta is equals to lambda by a, which is approximately equal to tan theta, which will approximately equal to theta. Write this down. Using wave theory, it can be shown. This will be proven in next chapter. Right now we are not proving this, we are just writing down that yes, it is our next part. Means this is a standard result and we are writing that standard result only. Okay. It means what? It means, like in traveling a distance z, the diffracted beam is, okay, first write down this, complete this first, complete it, written down.
So,
Now see, in any triangle, if this angle is theta, then what is sine theta? Sine theta is opposite upon hypotenuse. Okay, sine theta is opposite upon hypotenuse. So multiply hypotenuse with sine theta, we will get the opposite side. Okay, we will get the opposite side. Here, this distance is capital D. Here, this distance is capital D. Getting it? Now,
yes,
in traveling a distance D, the diffracted beam acquires how much width? If it is traveling a distance D, this is sine theta, or we can write also what? It is equal to tan theta as well. So, if this distance is D, then what will be tan theta? Tan theta will be equal to opposite upon adjacent, opposite upon adjacent is D. So its width will be equal to D into tan theta, and tan theta is what? Tan theta is lambda by A. D is lambda by A. Getting it?
Amma,
Getting this?
yes, sir.
Amma,
Now, this is the width. If this width is comparable with the size of the object, Fresnel distance is that value of distance at which this
Amma,
spreading due to diffraction becomes visible.
Amma.
If the spreading, are you getting what I'm saying?
Yes,
I
sir,
am
yes.
saying that light, whenever light is incident, it is spreading like this. It is going in this direction. But we are not able to see that. When we will be able to see that? When the image is larger than this object, when we will be able to identify, we will be able to identify when it is just double in size. Then we can see, no, 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 something is wrong. It is double in size. Okay. So that is our base mark. That is our base point. If we are seeing double the size of object, okay, that is Fresnel's or Fresnel distance. That is the Fresnel distance. Okay, this is equal to tan theta. So write down. Therefore, in a traveling,
మరి ఏమైనా రైస్ ఐటమ్
in
చేయగలవా?
traveling a distance, in traveling a distance, write down z. Traveling a distance z, the diffracted beam,
ఉన్నాయి ఉన్నాయి ఉన్నాయి
the diffracted
ఉన్నాయి
beam
ఉన్నాయే దుబ్బి
will acquire,
నేను బాగా చెప్తున్నాడే వాళ్ళకంటే
will acquire
కంటే బాగా చెప్తాను నేడు
a width Z Z lambda by A. From where we are getting this Z lambda by A? From this tan theta.
ఏంది పెద్ద లెక్క 5,000 అంటే
Okay. It was D lambda by A. And if it is not
అయిపోతుంది.
traveling the distance
లెక్క పెంచాడు
D,
కదా 5,000 వస్తుందంటే
if it is not traveling the distance D,
మనం
then
సేపు లెక్క పెంచాడు ఇంకా తీసుకోవాలా అని 200కే అనే ఫీలింగ్ ఉండదు అయిపోక మనకు. నువ్వేమంటావు?
if it is not traveling the distance D, if it is
కొంచెం
traveling
స్పీడ్
distance
చేస్తే
Z,
ఉంటుంది అంతే.
then this will be the
మాట్లాడతలే
acquired width of the light.
నోట్స్ కి టైం
Okay, this will
ఇస్తున్నాడు.
be the part B or B.
డాక్యుమెంట్ షేర్ చేసేయండి సార్.
Okay. Now in traveling distance Z, the
సిలబస్ అయిపోవాలి మరి
diffracted
ఎవరికైనా
beam is
కానీ.
acquiring this much width.
ఏందమ్మా?
Now comes the definition of Fresnel's distance.
ఈ శ్రీవాత్సవ్ కూడా బాగున్నాడు. అమిత్ శ్రీవాత్సవ్
Fresnel's distance.
బాగున్నాడు అంటున్నా.
Fresnel's distance
నిన్న రాత్రి 2 బిర్యానీస్ పెట్టాను కదా.
that value
ఏ
of
బిర్యానీ బాగుంది?
distance Z of
ఫస్ట్
distance
వచ్చింది, సెకండ్ వచ్చింది.
Z at which
సెకండ్ వచ్చింది.
the spreading due to diffraction
డబ్బు
spreading due to diffraction
ఇందాక
becomes
ఫస్ట్
comparable
బాగుందని చెప్పినావు. అది బాగుందా?
becomes comparable to the size
ఆ పైన కూర వచ్చింది బాగుందా పర్లేదా? నాకు అదే నచ్చింది.
to the size A. A is what? A is object
అదే
size,
పెట్టుకుంటానా?
or we can say size of opening.
20 to 25 బిలియన్స్ రాడంట ఆన్లైన్.
Size of opening. Okay.
నిన్నే
It means what?
ఫర్ దట్
It
ఎవడచ్చు.
means we can approximately equate
నేను మ్యాథ్స్ ఉంటాయి కదా. తెలుగు
the
ఆధారాలు ఇవ్వకొట్టేసి
spreading with therefore
ముందు తింటావా బిర్యానీ?
am I audible?
తింటా అని చెప్పు. సినిమా తింటూ చూసి
Yeah.
Hello,
Lagging, sir.
am I audible to both of you?
Hello.
Something happened here. I don't know
Yes, sir.
what. The screen.
the screen share has been stopped, sir, but you are audible.
Okay, fine.
Screen share has stopped.
So is this fine? Is the screen visible now?
So now it's visible, sir. No issues.
Fine. Now, therefore, the spreading width is comparable to what? Size of object. Size of object. Okay. What was the spreading width? Spreading width we just saw as Z lambda by A. This is equal to
బ్రహ్మాండంగా
A,
వచ్చేది ఏం కాదు.
or we can write Z is
More also.
equal to
3D మన 3D చూసినావు పాస్టర్ ఏమైనా ఉందా?
A square by
ఉంటాయి చూడు.
lambda.
సిటీలో
Z
షేడ్స్ కూడా
is equal to A square by lambda. Lambda is very, very small. Because lambda is very, very small, therefore, what will happen? Therefore, the bending will be negligible.
అదే
Bending will be negligible. When the bending will be negligible? When this A is very, very larger than Z lambda by A.
అంత బడ్జెట్ సిమ్రానే మరి 100 రూపాయలు టికెట్ ఇచ్చినాడు.
Since lambda is usually
10,000 రూపాయలు పడింది బడ్జెట్.
very small,
500 కోట్లే కదా. 250
therefore Z lambda by A is very, very smaller than A. Very, very smaller than A. That is bending. That is bending
సపోర్ట్ చేస్తాను.
is negligible.
ఏంది?
Now the bending is negligible. It means what? It means now we can consider light as traveling in a straight line. Now we can say that light is
ఏమి?
performing like rectilinear motion.
కానీ
It is moving in a straight line.
ఏమి?
When it is moving in a straight line, if this condition is fulfilled.
మొత్తం Okay, not a
If this
thing.
condition is
Not
fulfilled,
a
then light will be traveling, light can be considered to be
wall.
traveling in a straight line.
కోస్టల్‌లో ఇట్లుండదు మ్యాన్.
Okay,
అయినా ఈడనే
so write down
గవర్నమెంట్ ఏమైనా
if
రెస్పాన్సిబుల్ పెట్టింటారు. ఏందంటే
this
వాళ్ళు
condition,
తెలుసా?
if this condition is
ఆ!
fulfilled,
రాయలసీమలో రెడ్డి గారు
if this
డామినేషన్
condition
ఎక్కువైనా
is
అంత పెట్టి
fulfilled,
ఉంటారు.
then
ఆడ ఇంగ లెక్కలు ఇయకుండా ఏం చేస్తాడు పాపం.
light is set to move rectilinearly.
ఇన్ని చేస్తాడు ఆయన నాయకులు.
Then we can say that light is moving rectilinearly. Otherwise, we have to use wave optics. Getting it now? Hemant, you got your answer now?
సరే
I
గాట్స్.
think this is what you are asking.
యెస్ సార్.
Why we cannot use wave optics
యెస్ సార్, ఐ గాట్స్.
instead of ray optics. Got it now? Yes, what did you say? Hello?
సార్, ఐ గాట్ ఇట్ సార్. ఐయామ్ సేయింగ్ ఐ అండర్‌స్టూడ్.
Fine, fine. Chanakya, did you get it?
Yes, sir. Yes.
Taken down?
Yes, sir.
Okay, then. So this was our basic check or basic validity of wave optics and ray optics. After this point means if our object is very small, hello,
యెస్ సార్.
yes, my voice is clear.
యెస్ సార్.
Fine.
So you're lagging, sir.
So
Like
now let
in
us start. Even now it is lagging.
సార్, నో సార్, నో.
yes, sir. Like
Okay, fine. So
From
now let us proceed. Let us start with geometrical optics. Geometrical optics start with the rays of light. It starts with rays of light. What is a ray of light? Yes. How can you define a ray of light?
నో ఐడెంటిఫై సార్. సో అంటే ఇట్స్ ఎ పాత్
What
ఫర్
is a ray?
లైట్.
Path, we can say straight line path of transfer of light energy. Ray is what? Write down a ray of light is the straight line path of transfer of light energy. A straight line path of transfer of light energy. Light energy is transferring or moving from one point to another point through this path. This is called ray of light. This is point A, this is point B, and light is traveling from A to B. So this is a ray of light. Okay. Now, taken down this definition.
yes, sir.
Now we are starting with properties of light. Important. These properties of light, they are for geometrical optics. Okay. With the point of view of geometrical optics. So first point is rectilinear motion of light. Light travels in a straight line. Light travels in a straight line. Light travels in a straight line. It means what? This is nothing but rectilinear propagation. Rectilinear propagation of light. Rectilinear propagation of light. Okay. Next is, what is the speed of light? Speed of light in vacuum. Speed of light in vacuum is what? Hello, am I audible?
So 3
6.
into 10 power 8 meter per second. 3 into 10 power 8 meter per second. You can say.
Yes, actually it is 2.9979248. You can remember it as if a mobile number. Vacuum. I still have confusion regarding this spelling of vacuum. One module of motion, it spells it as W, and one module, it spells it as double C. On internet also, it seems that both are correct. I don't know how and why. Fine, that's another thing. So speed of light in vacuum is actually 2.9979245 meter per second into 10 raised to power 8 meter per second. This is the speed of light, actual speed of light. Means direct in meter per second, 299,792,458 meter per second. This is the exact speed of light, which is approximately written as 3 into 10 to the power 8 meter per second. It is denoted by C. C is the speed of light because it is universal constant. Because of that, it is denoted as C. Third point, third property. Third property of light is an electromagnetic wave. Electromagnetic
ఎవరో వెలవలోడు పని చేస్తా
wave
అన్నావు కదా తినే
as proposed by Maxwell.
మన పైన టికెట్ తీసి పెట్టమని
James Clerk Maxwell. He
17
proposed it.
ఎప్పుడు దొరుకుతాయి
It is an electromagnetic wave.
ఒకటి తీసి పెట్టమని
It consists of
నువ్వు వచ్చావా
it consists of
రేపు ఫస్ట్ ఓపెన్ చేయమని
varying
అడుగుతున్నా సినియాప్లో
varying electric
దించు కొట్టు
and magnetic
చెప్పాలనా
fields and magnetic
నువ్వు
fields. Means
కొంటాను
if this is
కానీ మోసం చేసేట్టు కళ్యాణ్ అంటున్నా మంత్లీ టూ టాపిక్స్ అయిపోయి ఈజీగా అయిపోయి కోటి పోతే ఇంకా నష్టం వాళ్ళకే ఇట్ మెంటల్ ప్రెజర్ గో టైం వేస్ట్ గో స్టూడెంట్ ఆదాయం కిందకి వస్తుంది అన్నీ ఉన్నాయి కదా డబ్బులు కడతారు ఇంకా మొన్న మంత్రులు బండి బలైంది పాతది
wait what
ఏంది ప్రభాస్ వాళ్ళంతా ఆపోజిట్ జగన్ కి వాళ్ళంతా టీడీపీ సపోర్ట్ ప్రభాస్ గారే కదా దాని ప్రొడ్యూసర్ వాళ్ళ కుటుంబం యూవీ క్రియేషన్స్ వాళ్ళ కుటుంబం అంతా వాళ్ళ అన్న తమ్ముళ్ళు అంతా వాళ్ళే నిన్నే ఈ జాతిరత్నాలు ఉన్నాయి చూడు సినిమా డైరెక్టర్ హీరోలు అంతా ఉన్నాడు నవీన్ అని హీరో అంతా వాడి వల్ల వచ్చిన వాళ్ళు వీళ్ళందరూ వాళ్ళంతా అంతే కదా బంధువులా ఇప్పుడు మనం జొన్నాలను తెచ్చింది ఎట్టా ఫ్రెండ్స్ బంధువులు ఫ్రెండ్స్ కదా ఫ్రెండ్స్ ఏమో అంత అంత ఉంటాయి కదా ప్రిఫరెన్స్ మనం వాళ్ళు ఇట్లా వాళ్ళు అంతా ఒకటి ఏమి మా విజయ్ దేవరకొండ.
Okay, so this is an electromagnetic wave. These waves are mutually perpendicular to each other. Light wave, if light wave is moving in this direction with velocity v, then this red part, this red part which is visible here, this is electric field. This is electric field. Okay, and this is z axis, this is y axis,
ఒక్కసారి అనుకుంటే నిజంగా
and this
అమెరికా
is
లైఫే
x
బెటర్
axis.
అనిపించండి, అది లెక్క మాత్రం ఉందండి.
And this part, which is along the z axis, it is denoting magnetic field B.
తీసుకోవాలి కానీ ఫస్ట్
This is the
అదే
magnetic
ఉన్న
field
ఐఐటీలు
B,
కూడా మంచి ర్యాంకర్స్
and
ఉంటారు
this
కదా,
is the electric field
వాళ్ళకి మాత్రమే ఉంటాయి.
E.
ఇప్పుడు ఈ మాలోళ్ళకి చేర్చారా ఏమి?
Light is moving in this forward direction. Okay, velocity of the light is in forward direction like this, positive x-axis.
అసలు
So,
ఫ్రెండ్స్ అవుతారా అమెరికన్స్
uh,
ఇండియన్స్ తోడా?
in short, we can write it like this.
ఇండియన్స్
This is
కాదు,
the electric field.
బాగుంటారా? కుల
This
వ్యతిరేకత ఎట్లా చూపిస్తారు?
is the magnetic field, and velocity is like this. V
ఆ,
B. Velocity is what? Propagation of light. Okay. These electromagnetic waves have
ఏదో.
several wavelengths.
ఆ?
Means there is a particular band from 1 meter to 1 meter to one into 10 to the power minus 11 meters. 10 to the power minus 11 meters is the wavelength of gamma rays. Below that, these are gamma rays. They have frequency approximately 10 to the power minus 11 meter wavelength, not frequency, wavelength. Okay, and before gamma rays, they are X-rays. X-rays have lower wavelength, means we can say that higher wavelength. So it is nearly about 10 to the power minus 9. And before X-rays, it is ultraviolet rays. Ultraviolet rays, UV rays are there. Before UV rays, Vibgyor, violet, indigo, blue, green, yellow, orange, red is there. So violet, it generally starts from 3500 angstroms, 35 or 3600 angstroms, and red, it ends at 7500 angstroms. At some places you will see 77 or 78 or 76 as well. So 78 is the last limit, and after that infrared rays are there. So these are the visible light rays. Infrared rays, before infrared it is microwaves, and before microwaves it is radio waves. So radio waves, microwaves, infrared, then visible light. This is visible light. Okay, this visible light is that part which we are going to study
ఫోన్
here.
చేస్తారు ఏంటి
This is full chart is called as
ఆయన? ముఖ్యమంత్రి
electromagnetic spectrum.
నిన్నే ముఖ్యమంత్రి
Electromagnetic
కూడా ఏం సార్ అడుగుతారేమో.
spectrum. It was proposed by uh, this Maxwell, and
అదే
as
వెంటనే
per this electromagnetic theory, this
కావాలి.
velocity of light, this velocity of
కాదు,
wave, it is
వేగంగా
given by frequency multiplied by lambda.
ఈ నెల 10వ తేదీకే
Frequency
కావాలని
multiplied
ఈ
by
రోజు ఫోన్ చేసి ఉంటాడు.
lambda. Okay. It means what? It means as the lambda increases,
ఆ,
the frequency will decrease. Frequency will decrease as the lambda
ఆ,
increases. Getting the point? Speed
Yes.
of light will remain same. Speed of light will remain same,
అతని ఫోన్
but
ఇదే లెక్క
for
కదా.
different colors,
అరుణాచలం పూజ.
lambda is different, and that's why their frequency will also be different.
అప్పుడు
Getting my point?
ఉండవు మా.
Yes, sir. Yes.
Taken down till this point?
No, sir.
సార్ కాపీ సార్. సో 15,000
Okay, fine.
అప్పటికి టికెట్లు
So
ఉండవు, అది
it's
సమస్య అంటలే.
8 o'clock now.
అడ 15
That's
మంది
all
16
about
మంది
today.
పోతే అసలు పంపిస్తారు.
Done, Chanakya?
Yes, sir. Yes, sir.
Fine then. So you got this diagram. Or these both of these fields are perpendicular to each other. So I tried to draw it likewise so that they may both look perpendicular to each other. This is what electromagnetic wave is. Okay. So that's all for today.
సార్ హలో సార్.
Where's our meeting?
హలో సార్.
Yes, hello.
Sir, how many classes it will take to complete this optics? I mean, general aspect.
How many classes? It actually depends. It actually depends. Uh, where's our meeting? Okay, this is our meeting. Fine.
Depends on the-
Fine. Okay then. Thank you. That's all for today. Generally, it will take around means full optics you are talking.
Sir, yes, a full ray and wave both combined.
Ray and wave both. See,
Yes.
ray optics alone it takes nearly 15 sessions, 15 classes, and 10 more classes for wave optics. So generally, 25 sessions are required
Yes.
along with the practice.
Yes.
Along with the practice, counting the practice.
Yes, sir. Okay, sir.
Fine. Okay, then that's all for today. Thank you, everybody.
Thank you, sir.
Sir,
Sir,
thank you.
but from tomorrow, like, we will not do this, like, geometry.
Ah, fine,
From
fine, fine. We will continue on Google. Google Meet is fine then.
or
Okay.
Zoom is better, sir. Like, you can on your video and share the screen.
Yeah, I know that Zoom is better, but again, Zoom hangs a lot. It hangs a
Mhm.
lot on this tablet. I don't know why it hangs a lot, but whenever when I was using that for uh, other classes, it was just it hanged up and I had to restart the meeting. That's why I left that out. Okay, fine. That's all for
Okay, sir.
today. We will continue with the Google Meet.
Okay, sir.
Okay, fine. Thank you.
Sir, thank you, sir.
That's all for
Thank
today.
you, sir.